At the University of British Columbia, all undergraduate students have one thing in common. They all write exams at the end of each semester within a 2-week period. Have you ever wondered how this exam schedule gets produced? There are more than 100,000 exams being written this April with only 4 time slots each day, and more than 29,000 students. Not only that, this schedule needs to be created 3 weeks after the final add and drop date of courses. With these kind of constraints, there needs to be computer software that can make the process easier to come up with the best possible schedule. That's where a team of researchers at UBC comes in. Dr. Holger Hoos, a researcher and professor in the Faculty of Computer Science at UBC, collaborated with Chris Fawcett and Dr. Marco Chiarandini in 2007 to create a solver that would make viable exam schedules. PhD student Chris Fawcett, who graduated from SFU with a computer science and mathematics degree, has been working with scheduling in some form for the last 9 years.
Yeah, I've been programming since grade 5, something like that. My elementary school teacher in grade 5 was awesome, so he just kind of gave us free rein to just kind of sit in the computer in the back of the class and do whatever we wanted.
Chris took his years of experience to building the post-enrollment course timetabling problem.
Well, the system involves this process of automated algorithm configurations.
An algorithm is a step-by-step procedure used to accomplish an end goal. An example of this is the Google search engine, which has its own set of guidelines by which it searches to come up with the best results for each individual.
So the actual solver that we use has a lot of parameters that can either be set by a human or tuned automatically by a piece of software, but the values of all of those parameters really matter in terms of how well the solver does.
Essentially, the solver that they created uses a basic algorithm to conduct a local search.
The idea is that you kind of make a proposed schedule whatever way you can, and then you do small modifications to it that improve its quality. So in this case, we start with a schedule that has no exams placed into times or rooms, and then just at random we select an exam, and then we decide where to put it. And so you just keep on just picking an exam, placing it, pick it, place it, and then once they're all placed, you probably have lots of hard constraint problems.
The solver works around the hard and soft constraints that are coded into the program.
Hard constraints refer to things that absolutely have to be satisfied no matter what. Like the solution to the problem doesn't even make sense unless they're satisfied. So in this case, it's just not physically possible for a student to write 2 exams at the same time. So that's why that's a hard constraint. And the soft constraints are really preferences, like you'd really rather not write in the morning, or you'd really rather not write 2 exams in the same day.
Additional hard constraints include only one class can be assigned for any given room and time slot, and all classes need to be assigned to suitable rooms, which meet the capacity of each class size. The solver uses these constraints to help produce a working schedule.
A lot of really dumb things put together can be something smart, right? So you kind of keep moving things around and just shuffling constantly, and you can end up finding really good schedules that way.
At UBC, there are 48 slots in which to fit 1,700 final exams. The set of criteria is fulfilled by the program to generate a possible timetable. This system has been implemented at UBC since 2009. Previous to Chris's algorithm, the exam scheduling process was done manually. However, even now, it's constantly being refined as more data is compiled. Furthermore, Chris and his team are working on refining the system to make it accessible for other timetabling algorithms.
We're trying to extend the solver to work with other timetabling problems, so things like, especially here at UBC, picking curriculum scheduling. So being able to do that in a smart way would be really helpful to universities. Then they'll be able to get better enrollment numbers, and hopefully, I think what the university really wants is to try to shorten the path that students take to finish a degree.
Chris hopes to commercialize the software so that it is used in other universities and possibly various other settings.
So our lab is really focused on providing tools to kind of help people design algorithms.
The general framework of the algorithm can be used for other timetabling situations with just a few minor modifications. Schedules for nurse rostering and restaurant work shifts can be simplified using the same tools.
Because it's a huge problem, and the current solutions that are out there are terrible. really, really bad. You have people phoning each other, can you take my shift? And then you have to log into some antiquated system, or maybe you don't even have a computerized system to handle it. So yeah.
Although UBC has not fully adapted to using this system, it is hoped that after further improvements and adjustments, this program will be fully integrated into UBC's scheduling services and other similar venues. But for now, Chris is busy with the tough problem of providing a working exam schedule for 29,000 undergraduate students.